Geometry Standard 9. We're going to actually get into the learning targets now, and we're going to put learning target 1 and 2 together, but we're going to do each movement by themselves. So the first movement we're going to look at is translation. So the learning standard, again, is analyzing transformation. Our learning target is I can verify and explain how an image remains congruent after the pre-image has been transformed by translation and can describe the changes that occur to the X and Y coordinates of that figure after that translation, which is known as the coordinate notation. A lot of information there, a lot of things we're going to do. I'm going to walk you through it here and we'll get started. So we'll look at the first thing is just the vocab. So we talked about translation on the last video. Just going to remind you what a translation is. So translation moves every single point of a figure the same direction and same distance. So if point P moves 3 to the left and 5 up, so will every single point on that figure move that same direction and that same distance. So left, right, up, down, and then the distance of how far. So the translation can move a figure, as I've said, left and right, and then also up and down. So that's the part of the direction. So you're going to hear you have to translate it left, right, or you can up, down, or a combination of both. And then again, remember, I'll sometimes call it a slide. So translation is also known as a slide. So our first one is translate the figure 5 units left and 2 units down, and then record the coordinates of the pre-image and image in the table. So we're going to start here. And how you do this is you just pick a point, and then you move that point, and then you move every single point on that. So A is right here at 2, 4. So while I'm saying that, let's just write down here. So A is at the point 2, 4. And we're going to move it again, 5 left and 2 units down. So count 1, 2, 3, 4, 5, and 2 units down. 1, 2. So right here, at this new placement of -3, 2, that is where we're going to put A prime. And remember, prime just means that is the image, the point that has been moved. So we'll label that A prime. Do the same thing with B. Count 1. So I should go left first. 1, 2, 3, 4, 5, and 2 down. 1, 2. So it looks like right there. So B, go back here, is at 6, 7. And now B prime, the move point, is at 1, 5. Yep, I put that wrong one. So 1, 5. So erase this point right there. 1, 5. And then we're going to move C. So again, count 1, 2, 3, 4, 5, 1, 2. So it looks like it's right here. So we'll put our information there. C was at 7, 3. And C prime now is at 2, 1. So we're going to take your straight edge. It'll look better than mine. This is B prime. And then we label this one C prime. Now, when you get done, if the figures are not congruent, so remember from the last lesson that if you translate a figure, which means just slide it up, down, left, or right, the figure should be congruent. So if you look at them and they're not congruent, that means you did not move one of your points correctly. Now, what I want to start to notice is some type of trend. And I want us to look from X to X, because that's what's going to ask here. What is any patterns that is happening to the X values and the Y values? So every X to every Y, X, and every Y to every Y. So we're just going to start here. The point A starts at 2 on the X and went to -3. The point B is at 6 and went to 1. The point C is at 7 and went to 2. So I notice there's a decrease. So I can say the X values decrease. And then if I look closely, I'm going to notice how much change or how much decrease it is. So from 2 to -3, that's 5. From 6 to -1, that's 5. From 7 to 2, that's 5. So the x values decrease by, we'll put that word in there, by 5. If we look at the y values, y values. So it starts at 4, it also goes down to 2. Starts at 7, goes down to 5. Starts at 3, goes down to 1. So notice really quickly, I can say they decrease because they're going down in value and by 2. Now, why is that interesting? If you go back to what we did, we took each point and went left 5 units, and we went down 2 units. So if I take an ordered pair up here, we'll just do A. So A was at 2, 4, and it changed to, so our A prime was -3, 2. So we're going to work on this, what we call the algebraic expression, or from the learning target, the coordinate notation. So what happens to the x and y values? Well, we just looked at the pattern here. All the x values decreased by 5, all the y values decreased by 4. So I'm going to show that algebraically. So those are my x's. So we could say x, because that's the variable we're working with. Decrease means subtract, and then we know it's by 5. And then the y, decrease, which is subtract, by 2. So that starts our algebraic expression. Every x value decreased by 5 and every y value decreased by 2. Now look at our movement. Notice this left has to do with the x value, because when you move on a coordinate grid, we'll go back up to look at the coordinate grid. When you move at a coordinate grid on the x-axis, you're moving to the right and you're moving to the left anywhere on the x. Okay, and when you move something to the right, just like on a number line, you're going to end up, it's going to be an addition. So it's going to be, you're going to always add if you move to the right. If you go to the left, just like on the number line, you go down in value, you're going to subtract. Same thing as the y's. Okay, so this is going, we're going to translate something up versus translate something down. If you translate something up, you end up adding to the x's. I'm sorry, to the y's. So we could put that, so the y value here, we're going to add to the y. And if you go down, you end up subtracting to the y. So go back to this problem here, looking at the algebra here, and this is how we're going to write it. I'll just write it right here for you. So we start out with just the normal xy. That was the coordinate pair to start with. In this case, it was 2, 4. You put this arrow, which means yields. And then you put what happens to the x and y in every problem or every point on our triangle. So x was subtracted by 5 and y was subtracted by 2. Okay, let's go to the next problem. So we have another triangle. This time they want us to take it 4 to the right. So if you remember what I said, if you go to the right, it's going to end up adding on the x. So it's going to be x plus something. And we're going to go 3 units up, which is this way. And remember, if I talked about that, that's y plus something. Well, if I quickly look, well, if I'm adding 4, that means I'm going to move that 4 to the right, means I'm going to add 4. And if I'm moving 3 up, that's going to add 3 to the y. So we'll count those out. So here is E. E is at -4, 1. And then we're going to write E prime here, our image. So we're going to count 1, 2, 3, 4. 1, 2, 3. So E prime just moved to 0, 4. Now, if you get tired of counting, like physically counting, you can just think about it. If you're at -4 and you know you have to add 4 because you're going to the right, well, -4 plus 4 goes to 0. So now you're here. And then if you have to add 3, well, if you're at 1 and you add 3, that goes up to 4. So once you get going, if the algebra of just adding the numbers instead of physically moving each point, you could use that strategy. I'll keep just moving them. This is 1, 2, 3, 4 to the right. 1, 2, 3. So this would be E prime. And if you want to connect the points so it doesn't get so confusing here, again, I would use a straight edge if I was you. So we just took D. So we'll put D here. And D is at -7. And all the way down here to -4. And D prime, we just move that to 1 over, 4 to the right, 3 up. We move that to -3, -1. Okay, last one we have to move is F. So count with me. 1, 2, 3, 4 to the right. 1, 2, 3 up. So there is our new F prime. And again, if I connect the points, it works better with a straight edge. I'm going to notice that these two triangles are congruent in size, which means I probably did something correctly. So I'm going to quickly write down that last one. F started at -3, it looks like -5, and it is now moved over to 1 and -2. So that's 1, -2. So let's look at the xy to help us with that algebraic expression. So let's look at the x's first. So -4 to 0, -7 to 3, -3 to 1. Well, it looks like the x values increase by, and that should shock you, by 4. And we kind of knew that already if you go back up here in my thought process up here, since we're going to the right, and the right is on a positive side, like the positive side of a number line, meant we were adding 4. Okay, the y value, I could say values. So let's check out those. So 1 to -4, -1, sorry, -4 to -1, and -5 to -2. Well, those are all increasing too. So we're going to write increasing, or increases by, well, -5, and you're going up to -2, that's by 3. Again, that shouldn't shock you because if you go way back up here, we already said that because we're going up on the y value. That means we're going to add. So write this algebraically. So we'll just pick a point here. We'll pick F. So F was at -3, -5, and it went to +1, -2. So on this x here, again, we already talked about it. We saw that was increasing by 4. If you're at -3, -2, -1, 0, 1, that is taking the x and adding 4. And down here, if you're at -5, you're going to add -4, -3, -2. That's adding 3. So our algebra expression starts with our xy. That just means every point starts at xy, and then every point, if we go back here and I could pick another one to pick, moves the value of x, adds 4, and the value of y adds 3. Okay, next problem. This time they are moved for us, or translated for us, so we have to come up with the verbal description. So we're just going to write down these letters here: G, H, I, and J, and it doesn't matter which order you put them in. So we're going to look at G here, and I'm going to start with the pre-image, which means there's no prime. So that's at 2, -7. H is at 2, -1. I is at 5, -1. And J is at 5, -7. So we're going to look at the image. So G prime, H prime, I prime, and J prime. So G moved all the way to -5, -3. H moved to -5, 3. I moved to -2, 3. And J is now at -2, -3. Okay, and one thing we have to describe down here was what we're going to end up doing is describing the translation, which in other words, how far did it translate and what distance? And remember, the same distance, same direction. So I can just kind of tell you're totally moving this way to the left, and then you're moving up to get to H. Now you can count those. So you could sit here and go 1, 2, 3, 4, 5, 6, 7. So it looks like we moved left 7 units. And then 1, 2, 3, 4, up 4 units. Okay, so you can physically, kinesthetically move those. If you don't need the kinesthetic movement, you can kind of look at your points. So again, we're going to look at all the x's. So 2 to -5, 2 to -5, 5 to -2, and 5 to -2. Well, quickly I notice that is decreasing in value. So if I start at 2 and I go all the way down to -5 on a number line, that is going down 7. Same thing here. If I start at 5, I go down to -2, that's going down 7. So that doesn't surprise me. It's going to the left 7. Up 4. So we'll look at the y values, -7 to -3, -1 to 3, -1 to 3, -7 to 3. Again, increasing value. All of them, if you look at them really quickly, are increasing by 4, which again would surprise me because we know the translation moved up 4. So our algebraic expression would be x comma y. That means any of these points of the original points, if you take them and you you subtract 7 to the y, x, and to the y you add 4, you should get that. So let me do it backwards, give you an example. So let's say I knew I was at 5, -1. So that's the normal xy. And it yields, again, x minus 7, y plus 4. Well, if I didn't have a graph to look at, I can see that if I take 5 and I subtract 7, that is going to get me at -2. Because 5 minus 7 is -2. I'm at -1, and I go and I add, so I'm putting it right here, -1, and I'm adding 4. That takes me up to 3. So I can check here on my table, or I can go up to the example. That would be I prime, and I prime's at 2, -2, 3 is what we just looked at. What do you notice about the side or the line segments in the pre-image image? Do they change size? No. Since you're moving every pair the same amount, or every point the same amount, so does the line segments. They don't get any bigger, they don't get any smaller, they're exactly congruent. So do they change size? No. They remain congruent. Everything remains congruent when you translate. Okay, next problem. We got another one. This time, if you want to pause it, try it on your own, and then see if you get the same answer I do at the end here. So we'll go K, L, M, N, K. So this one's our pre-image. Notice there's no prime on it. So it's -7, 2. L is -2, 2. M is -2, 7. And N is -7, 7. Now, if I kind of think about this, notice that we're going this direction to get to M prime. So to our right, which means we're going to add to the X, if that helps your brain. And then you can go down, which means we're going to subtract on the Y. So you can physically count those if you want to. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like we're going to go 9 to the right. So we're going to add 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like we're going down 9. So you have two choices here. If you've paused it, that's fine. But if you still need help, you could just go to K prime. You could look where it went. It's at 2, -7 right now. Or you can use what we just thought through. So the x was going to add 9. So if you're at -7, you add 9. If you need a calculator, please use it. That gets you to 2. That was right. And you're on the y. We're going to subtract 9, it says. So 2, and I take away 9, makes us in the negative amount of -7. So you can either physically look at the grid and the ordered pairs, or you can think about the algebra behind it. L prime, so again, I can look here. It's at 7, -7. Or I could have looked up here. You're going to add 9 to -2, which is 7, and subtract 9 from the y, which is -7. Again, do whatever's comfortable to you. So we can physically look up here. So m is right here. So that's at 7, -2, if that's easier for you. But a good check would be to quickly check it with the adding of the 9 on the x and subtracting 9 from the y. And then n is at 2, -2. And we'll quickly check that one. If you're at -7, you go down to 2. I'm sorry, not down. That would be up to 2. Yes, that's adding 9. If you go from 7 to -2, that's the subtracting. So verbally, we can go back to our arrows. We went right 9, and then we went down 9. So right 9 units and down 9 units. I just call it units because I don't know how much distance that is. The algebraic expression, so xy would just be any point, so any of these points that we just picked. And what happened to them is that the x's went up 9 and the y values went down 9. And the last question, what do you notice about the angle measurements? Well, I'm going to hope from remembering before, we don't change the shape. They're congruent, and congruency means the angles are the same. So do they change sizes? The answer is no. They remain congruent. So the moral of that story is it doesn't matter if you translate it left, right, up, down, how far, it always, or the shape always remains congruent. Same size, same shape. So this is going to test your algebra skills and just describing what's happening. So I'm going to use the idea of looking at my x to x. So am I at 12 and I go down to 1, that means my x values are going down, and 12 to -1 is 13. And then I'm going to look at my y's. So it's at 7 goes up, so I know I'm adding. 7 to 14 is 7. So how to describe that? You start always with the x. So the x is going this way. And since I'm subtracting, I'm going to the left. So left 13 units. And the y's go up and down, but I'm going positive, so it's up 7 units. Okay, look at the next one. -6 to -5, that's a little tiny increase of 1. And then -8 to 10, that's also increase of 10. So think again, x axes go this way, but we're adding, so we're going to go to the right 1 unit. And then the y values, which is, remember, up and down, since it's going up, it's positive, I should say, we know that it's going up 10 units. And the last one of these, check it one more time, look at the x. If we're at 3, we go down to get to -9. So the x values are going down, which means subtraction, and that is by 6. The y values, 6 to -1 is also going down, and that's by 7. So think again. X-axis goes this way, but if we're subtracting, that is to the left. So left 6 units. And then the y, remember, is going this way, but we're going down because it's subtracting. So we're going down 7 units. And the last page. So if you were listening very carefully, this looks just like your CFU that you will be taking at the end of your practice packet and your IXL lessons. So we're going to read it. It says translate, and that's what we're working with. This lovely rectangle right here, 5 units to the right, 7 units down. So you can just start counting if that's what you choose to do. We'll start with X here. So 5 to the right, 1, 2, 3, 4, 5, and then 7 down. So 1, 2, 3, 4, 5, 6, 7. So we're sitting right there. Now, if you don't like to do the counting, if that really confuses you with all those boxes on there, you can take the X and you can do the algebra side of it. So if you're at -7 and then you go up to 8 here, and if we go over here, think about the algebra here. If we're going right 5, that means we're take the x value because that's right or left on the x-axis. We're going right, which means we're adding. And the y is up or down. Since we're going down, we're subtracting the 7. So I can just look at this. If I know my original, I know that I'm going to add 5, which means that x prime is going to be at -2. And then the 8, if I'm going to subtract 7, 8 minus 7 is 1. So I could go just to plotting it if you don't want to count it. And we'll count it again here. We're going to start with y. 1, 2, 3, 4, 5, 5, and then down 7. 1, 2, 3, 4, 5, 6, 7. So this one's y prime. This one's x prime. Again, you could do the algebra if that makes it more sense to you. W here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So if you want to start putting your lines together, you can start seeing the shape, and then Z, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So this would be Z prime. So again, you can use the algebra that I showed you, and I can show you more points if you want to. You want to come up and ask me questions, or you can just count too. Notice again that the two shapes are congruent. Same size, same shape, same everything. Line segments are equal, angles are equal, everything is equal. Over here, just quickly corresponding. So if we look at WX, this one right here, of course, the corresponding is W prime X prime. Look at W, let me change colors, it's so confusing. XY, here's XY. That, of course, corresponds with line segment X prime, Y prime, Z, or sorry, YZ, which is this one right here. That, of course, corresponds to this one down here, which is Y prime, Z prime. ZW right here corresponds with the ZW prime. So Z prime, W prime, and then put the line above it to be the line segment. The last thing is corresponding angles. And of course, I've said this over and over, they don't change size. So here's W, and then W prime would be, of course, the corresponding. And then X, X prime, Y, Y prime. Ooh, my angles are getting ugly. And then Z, Z prime. And that's it. Hope you have a great day.